protocols. Some NEXT devices have the ability to route layer 3 packets, but others are strictly layer 2 devices, and implementing the different types of routing protocols is different from doing that in iOS devices. Coming up, I'll cover ground on static RIP, EIGRP and OSPF routing protocols, plus guide you through configuring each of them. I'll keep the configurations pretty basic, but no worries, I'll include enough for you to understand how they work, how to configure them, even how to verify that each is running properly. I'm going to use the internetwork pictured in figure 10.2 as a reference for all configurations throughout this chapter. Here you see three Nexus switches, one 700 series and two 500 series, named RA, RB, RA and RB are pre-configured for this chapter. Also present is RC, which is an ISR router connecting to an ISP. We're going to focus on configuring the Nexus 7000 in this chapter. Okay, so let's start by taking a quick look at the default routing and then zero in on the routing protocols. But first, let's set up our interface configurations on the Nexus 7000. Switch config, hostname Nexus 7K, INT E3/1, no switch port, IP address 172.168.10.0.255.255.255.0, no shutdown, INT E3/2, no switch port, IP address 172.16.20.1, 255.255.255.0, no shutdown. I went to the two Ethernet interfaces and first made them layer 3 ports using the no switch port command. Then I added the IP address and enabled the ports with the no shutdown command. Since our other two interfaces are already configured with IP addressing and routing protocols, we'll start communicating with them as soon as we configure routing on our 7000. Static routes. Which type of routing uses the least bandwidth? You guessed it, is creating static route wins, and in small environments static routes can just be the thing you need. In places where you only have a single possible path to the destination, static routes are ideal. One of the most interesting cool features is that you can enter the destination subnet mask as a dotted decimal or CIDR notation. Let's take a look at the basic NXOS syntax for static routes. Nexus 7K config IP route $ABCD I prefix in format I.I.I.I ABCD/LEN IP prefix and network mask lent in format X.X.X.X/M. The Nexus OS allows us to specify a default route by using a network of 0.0.0.0 and a mask of /0, which is different than the iOS configuration. Here's an example. Nexus 7K config /IP route 0.0.0.0/0 ABCD IP next hop address in format I.I.I.I ABCD/LEN IP next hop prefix in format I.I.I.I/M Ethernet 2 IEEE 802.3Z MGMT management interface null interface port channel interface VLAN interface. The next part of the command specifies the destination, either an IP address of the next hop or our exit interface on the 7000. We typically won't bother using the exit interface because even if we configure the default route using the exit interface, unlike in the iOS configs, NXOS demands that the next hop IP address be configured regardless. So what's the point? It will look something like this: IP route 0.0.0.0/0 interface exit interface. Using our figure as an example, we'll just simply use the next hop IP address of 172.16.20.2, which is in the direction of our ISP. Here's a typical configuration of a default route that will work great in our example. Nexus 7K config IP route 0.0.0.0.0172.16.20.2, and we can easily verify it via the show IP route command. Nexus 7K config #sh IP route table for V or F default denotes best ucast next hop, denotes best mcast next hop, XY denotes prefix / metric 0.0.0.0/ ubest mbest 10 via 172.16.20.2 ETH 3/2 1/1 00:01:14 static 172.16.10.0/24 ubest mbest 1/0 attached via 172.16.10.1 ETH 3/3/1 00:08:32 direct. Okay, I think I might have read that. 172.16.10.1/32 ubest mbest 1/0 attached via 172.168.10.1 ETH 3/1 00:08:32 local 172.16.20.0/24 ubest mbest 1/0 attached via 172.16.20.1 ETH 3/2 00:08:07 direct 172.16.20.1/32 ubest /mbest 1/0 attached via 172.16.20.1 ETH 3/2 00:08:07 local Nexus 7K config. By looking at the route table output, you can see that the single entry on top is our default route listed as statistically configured. With the next hop via 172.16.20.2, this basically instructs that if a packet arrives with a destination address absent from the routing table and matching no entries therein, just pawn it off to the neighbor router. The other entries in the routing table are directly connected interfaces. This demonstration of setting a default static is vital because it's the most common use of a static route in modern networks. Next, I'll cover RIP and then dig deeper into some dynamic routing protocols. RIP. As I said, configuring some routing protocols with NXOS is very different from doing it with an iOS NX OS is designed as a data center operating system and can run a bunch of instances of various routing protocols simultaneously, but for our purpose, we're only going to use one instance of each routing protocol. Understand that when we start a routing protocol, NX OS will require us to confirm that the feature is enabled first. After that, we've got to give the routing protocol an instance ID, which we'll just make up and then enable it on certain interfaces, and then we'll use the address family command to choose either IPv4 or IPv6 for RIP, and then we'll enable it on certain interfaces. Let's see how our configuration looks on our network. Nexus 7 config feature RIP, Nexus 7K config router RIP, Todd RIP, Nexus 7K config router address family question mark, IPv4 configure IPv4 address family, IPv6 configure IPv6 address family, Nexus 7K config router address family, IPv4 unicast, Nexus 7K config router AF INT E3/1-2 Nexus 7K configure if range IP router RIP Todd RIP. Notice that we ensured that the RIP feature command was enabled first. If we didn't, we'd get an error when trying to configure it. You can see that when we created an instance of RIP called Todd RIP and specified it as IP version 4 with the address family command, then we went to our chosen interfaces and enabled RIP for process Todd RIP on each interface that we wanted that process to run on it. And to verify the configuration, we'll use the show IP route command, which has replaced the show IP protocols command we used in iOS routers. Nexus 7K SH IP RIP, process name RIP Todd RIP VRF default RIP port 250 multicast group 224.0.0.9 admin distance 120, updates every 30 seconds, expires in 180 seconds, collect garbage in 120 sec, default metric 1, max paths 8, process is up and running, interface supported by IPv4 RIP Ethernet 3/1 Ethernet 3/2. The preceding output shows the following: the process's name, the UDP port number, RIP is using 520, the multicast group address of 224.0.0.9, RIPv2 address, the AD multiplied by the maximum path that RIP will load balance by default, which is 8 by default but can be configured to 16. The interface running the RIP process Todd RIP. Let's take a look at the routing table using the SHIP route command. Nexus 7K SHIP route output cut 0.0.0.0/0 ubest/mbest 1/0 via 172.16.20.2 ETH3 /2 1/000:22:20 static 172.16.10.0/24 ubest mbest 1/0 attached via 172.16.10.1 ETH3 /1 0/000 29 38 direct 172.16.10.1/32 ubest mbest 1//0 attached via 172.16.10.1 ETH3 /1 0/0 00:29 38 local 172.16.20.0/24 ubest /mbest 1/0 attached via 172.16.20.1 ETH 3 /2 0/0 00:29 13 direct 172.16.20.1 /32 ubest mbest 1/0 attached via 172.16.20.1 ETH 3 0/2 0/0 00:29 13 local 192.168.10.0/24 ubest mbest 1/4/0 via 172.16.10.2 ETH 3 /1 120/2 00:10 47 RIP Todd RIP 192.168.20.0/24 ubest mbest 1/0 via 172.16.20.2 ETH 3 /2 120/2 00:11:04 RIP Todd RIP. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.